All right, geometry lesson 42. Let's see, finding distance from a point to a line. This starts off in your book on page 273. Given if we have something like line AB that we see there on the board, what is the shortest distance between point P and line AB? You want to notice that triangle ABP is a right triangle, and line AP is a hypotenuse. The hypotenuse is always the longest side of a right triangle, so AP must be longer than PB. So the shortest distance from point P to the line AB is not going to be the line AP. In fact, what we should learn is that the shortest distance is PB. It will always be the perpendicular line that connects a point to a line that it's not on. And that's where we get into some of these theorems that are going to state these things. So through a line and a point not on that line, there exists exactly one perpendicular line to the given line. Okay? So there's only one line that will go from a point not on a line to a line that is perpendicular to the line that it's not on. Well, that's not going to get annoying. Okay? Theorem 42-2, the perpendicular segment that connects that point to that line is the shortest segment. So it'll have the shortest distance. So, I mean, it's kind of as the frame goes, the shortest distance to points is a straight line. Well, if we want to be more specific, the shortest distance from a point to a line is a perpendicular line. Okay? All right, so, I mean, you think about it this way. If you were lost in the woods and you knew that there was, well, maybe not lost, but if you're in the woods and you're trying to walk to the highway, right? Let's say the highway is straight, right? You want to get there as quick as possible. You want to find if you know approximately the angle or the slant of the road based upon where you are, you want to walk perpendicularly back to that road. That's going to get you the shortest distance. Okay? I don't know, but in my head, I envision being able to use that, in an approximate general sense, is that if I was out hunting, a lot of times I'd walk back to the road and back to the vehicle rather than trying to walk through the woods some way, right? Usually the easiest path is back to the road. Anyway. All right, so Theorem 42-1 indicates that there's only one such segment. That's going to make our life a lot easier because it means that we're subtracting the guesswork out of it, okay? That, well, it could be an infinite number of lines. No, it can't. The length of a perpendicular segment from a point to a line is referred to as the distance from a point to a line. Okay? Theorem 42-3, that perpendicular segment from a point to a plane is the shortest segment from the point to the plane. So same concept, it works for a line or plane. Because parallel lines are always the same distance from one another, the distance from any point on a line to a line that is parallel to the same, regardless of which point you pick. If two lines are parallel, then all points on one line are equidistant to corresponding point on the other line. All right, that's it. Let's check into some questions here that we can answer. All right, if we want to find the distance in units from point -9, -5 to the line x equals -4. What's unfortunate about some of these questions that come up is that they're the absolute easiest form of what we can do. You'll notice, what kind of line is x equals -4? No, what kind of line? It's a horizontal line. No, it's not. It's not a horizontal line. It's a vertical line. Okay, it's a vertical line at x equals -4. So if you understand that, then you'll understand that the distance that we're looking for is the distance between the x value of -4 and the x value of -9. So the distance is only 5. The line is undefined, has an undefined slope, but the distance between the point -9, -5, and the line x equals -4 is 5. Let me show you. Okay, let's go back to this. Okay. All right, so our coordinate was -9, negative 5. Our line was x equals negative 4, right? All right, so, okay. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that ought to give us enough. Okay, the line x equals negative 4 would be right here, correct? Okay. The point, negative 9, negative 5. All right, so, well, I guess we need some down here. 1, 2, 3, 4, 5, 6, 7. Okay, and granted, this would be a whole lot better on an actual coordinate gridded out plane. All right, but negative 9, okay, is going to be negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 5. Okay, let's see, 1, 2, 3, 4, 5. Okay, because it's a vertical line, what line is always perpendicular to a vertical line? See you saying it. Horizontal. Okay, so a line that's coming straight across like this. Okay, that's going to be the shortest line because that's a perpendicular line. Okay, so now all I'm having to do is count 1, 2, 3. Well, it should have been maybe over a little bit more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, my line should have been, this point should have been over a little bit more. Okay, what's the distance? 5. So if I have any point, and I'm trying to find its distance to a vertical line, the distance is always going to be the difference between the x value of my coordinate and the x value of the vertical line. Okay, what's the distance between negative 9 and negative 5? Or sorry, negative 9 and negative 4? It's 5. Okay, now the same thing is true of horizontal lines. Okay, let's go back. Okay, notice this next one. We want to know the distance from negative 8, 1 to the line y equals 5. Well, y equals 5 is a horizontal line. What kind of line is perpendicular to it? A vertical line. So in the end, all I'm looking for is the difference between 1 and 5. What's the difference between 1 and 5? 4. So the distance is 4 because a vertical line is horizontal to a horizontal line. Okay? Now, do I need to draw you a picture of how that would work? Okay. You get the same thing with number 3. So what am I looking for the difference between? 13 and negative 6. Okay? So that's bigger than just 13 and 6. That would be wrong. So I'm 6 plus 13, right? Because from negative 6 to 0 is 6, and from 0 to 13 is 13. So it's 6 plus 13, which is 19. Do we get that? Think of it as at that point, think of it as a number line. Okay? Here's 0, here's 13, there's negative 6, right? From here to here is 6, from here to here is 13. I got a distance of 19. Does that help? Okay. All right. All right. So like I said, these are keeping it really, really easy. As soon as I think we got like one more question in here though, that is not that easy. Okay. A school provides a bus service only to students who live a distance greater than 2 miles from the school. On a coordinate plane, the school is located at the origin, so 0, 0. Michael lives at the closest point to the school on Maple Street, which is represented by the line y equals 5x minus 4. If each unit on the coordinate plane represents 1 mile, does Michael live far enough from the school for the bus service? This question has showed up on a test before. Okay? So what we're looking for, okay, here is the school at 0, 0. He lives on a road, okay, at y equals negative 4. So we're going to go ahead and negative 1, negative 2, negative 3, negative 4. Okay? And this is where you would really be better off with a grid, but in any case. So we got a y-intercept of -4. It's going to go up 5 over 1, right? 1, 2, 3, 4, 5 over 1, 1, 2, 3, 4, 5 over 1. So we get a road that looks something like that, but we can't guess at it. Okay? So, let's see. This is what we have to do. All right? We know that we need a line that is perpendicular to that line, right? All right? So if we're talking about perpendicular lines, what are we looking at when we are looking at that word perpendicular? It's referencing what? Is it referencing the y-intercept? Or is it referencing the slope? What do I know about perpendicular lines? Two lines that are perpendicular have a right angle. What do I know about their slopes, though? What's their opposite? Not necessarily. Opposite reciprocal. Okay, so if it was negative before, now it's positive. If it was positive before, it becomes negative. So I do know this about the line that goes from here to here, is that I know that it has a slope of -1/5, right? Okay, so the line that goes from here to here has a slope of -1/5. Can anybody tell me, because the school is at 0, 0, what the y-intercept is? 0. So the equation of that black line is y equals -1/5 x, correct? Okay, so this takes a couple of steps to find that distance of that black line, because that's what we're looking for. We want the distance of the black line. In order to, we don't know that. I promise you we don't know that, and I'll show you that we don't know that. All right, so the first thing that we need to find out is what is the coordinate where those two lines intersect at. What we're ultimately going to do is we need to find the coordinate of that green dot, and then we're going to find the distance from the school, which is the blue dot at 0, 0, and the green dot wherever it is, because it might be, it's not going to be at necessarily this nice, neat coordinate spot, okay? In order to do that, listen up, all right? We have y equals -1/5 x. We have y equals 5x minus 4. Where they equal, where they meet, is at that spot right there. So what I can do is say -1/5 x equals 5x minus 4. Okay, set the two equations of the lines equal to each other. That's where their x value will be. Okay? That makes sense? Okay? Because they both equal y, so I substituted -1/5 x for this y right here. All right. From here, I'm going to subtract 5x. Okay? So I have -1/5 minus 5. Yeah. It'd be -5 1/5 x, but it's going to equal -4, so I still have to divide by -5 1/5. Okay, so you said -26 over 5. Well, because I have to multiply by the reciprocal, so yeah, it's going to be, I'm going to multiply by -5 over 26. (20 over 26), which will probably reduce. Okay, should reduce. I mean, I can certainly divide that by 2 and get what, 10 over 13. Okay. All right. As a decimal, what does that come out to? What's 10 over 13? .65? Okay, 0.625. So the x-coordinate is 0.625, if you want to look at it like that. 10 over 13 is fine too. Okay, did it end at 0.625 or did it keep going? All right, good. Stopped right there. So if I want to find the y coordinate, how do I do that? Now that I know that x is 0, plug it in for x. Now the easiest place to do that is in this one right up here to the right, right? Negative 1/5 times 0.625. What do I get? You can give it to me as a decimal if it. Guys, I got a lot of people just staring at me. If I'm doing all the work, right, you're not being benefited. All right. Everybody check. We got negative 1/5. So I would do parentheses. Negative 1 divided by 5 times 0.625. What? Negative 0.125. All right. So it's not very far below the x-axis, correct? Okay. So our final step here is we want to find the distance between 0, 0 and 0.625, negative 0.125. Okay, distance formula, right? Now the thing is that it's a 0 minus, right? So I'm going to get that in both places. I'm going to 0 minus 0.625 squared plus 0 minus negative 0.125 squared. Ultimately, the 0 really doesn't matter. I'm getting 0.625 squared plus 0.125 squared. Okay, when you square rooted everything, so your final answer, what did you get? 0.637. Okay, so what you're saying is that he lives 0.637 miles from the school, correct? Okay, so is the bus going to come pick him up? No, because he has to live, he's got to live 2 miles away before that happens. Let's check. I don't know. It says 0.78. So let's see. We might have had something wrong in there. I mean, I was going based upon. I mean, we still got the same no answer. It's just a matter of. I'm confident up to here. Let's see, negative 1/5 x. Let's check a couple places to see if we can find an error. Okay. Okay. Let's see. Okay, all of that's the same. Okay. Our problem was with what you got right there. Should have been 0.769, not 0.625, which is going to cause everything else to be off. Okay, negative 4 times negative 5 divided by 26. Yep, is not 0.625. So let's start off by fixing that. 769. So that's going to change here, right? And once I've got 0.769, I still have to plug it back in up there. So we got negative 1 divided by 5 times 0.769, which is giving you negative 1.54. Okay, you've plugged in our new numbers. So the square root of 0.769 squared plus 0.154 squared, 0.78. Yep, 0.78. And Chandler, what was the answer? This is what we should get. Okay, so our problem originated there. Okay. Okay, so at this point what I want to do is I want to work out at least one question that deals with this from your homework. Your assignment was 15 through 30 all. I believe question number 15 is one that you'd want to be able to do. Okay, because it's, okay, on question number 15, what are the coordinates? 15, question 15. What are 4 and what? 4 and 15. And what's the equation of the line? 4x minus 1. All right, now what we should realize is that if we know the process, we can do this without drawing anything, right? Okay, so we know that we have to have the opposite reciprocal slope of 4, right? What's the opposite reciprocal slope of 4? 1/4. No, not quite. -1/4. All right, so we know y equals -1/4. But in this case, because we're not working with 0, 0, right, I have to actually plug in. Okay, so I can do y minus y1 equals m times x minus x1. Okay, that's going to give me y minus 15 equals -1/4 x minus 4. Okay, y minus 15 equals -1/4 x. -1/4 times -4 is 1. Positive 1, we're going to add 15. So y equals -1/4 x plus 16. All right, so these two equations, this one and this one up here, have to cross. Okay, so do we understand step 1? Okay. Okay, so we're going to set the two equations equal to each other. -1/4 x plus 16 is going to be equal to 4x minus 1. Okay, we're going to solve for x. We're going to add 1/4 x. We're going to add 1 over here. We're going to get 17 equals 4.25x. Divide by 4.25. What's 17 divided by 4.25? Four. Okay, so x equals 4. Okay, let's plug x equals 4 into our original equation. What's 4 times 4? 16 minus 1? 15. So y equals 15. Okay, now, final step. So this was step 2. This got my x and y values. Final step is that we know that now we need to find the distance between 4, 15 and So the distance is 0, and that's the answer. There's no distance between 415 and 415. So that worked out really nice, right? Okay, you have another one, though, that is not so nice. Well, actually, no, it's actually not too bad. Number 16 is just like what you saw in some of the practice set question, or the practice questions that we did. Notice that in 16, what kind of line are we trying to connect it to? Look at question number 16. What kind of line? A vertical line. So all I have to do is find the difference between what two values?
Oh, the x values.
The x value. So -2.15 and 11.3. And with that, like I said, in that case, okay, This is 11.3. This is what, negative 2 point, what was it? 15. So I'm going from this distance. Okay, so this is 2.15 and this is 11.3. So I'm going to add those things together. I should get something like 13.45. Okay, and that's my answer. Okay, so we've worked out both questions in this assignment to deal with this lesson. Does this make sense? Okay, I'm going to hit stop there then.